Hello everyone. Today I am going to explain one problem on two-port network parameters. So in this one, for a given network, they are asking to find out the Z parameters and H parameters. So this is the given circuit. So in this the given circuit, they given the two dependable sources, one voltage source, another one is current source. So we can't apply the KVL here. So we are going to apply a super mesh analysis here. So here in general in a given circuits we have the total 3 loops, loop 1, loop 2 and loop 3 are there. So in this one, in loop 1 and loop 2 we can't apply the KVL directly here. So we are going to apply a super mesh analysis. So apply super mesh analysis for loops 1 and 2. So the super mesh analysis is nothing but it. So when we are not able to apply the KVL to a loops, then we are going to combine these loops because there is a common current source in between the two loops, and that current source it should be equal to whatever the currents in that current source. So here the point 1 V2 is equal to that current source is equal to I1 minus IB, because here I1 is your entering current, here IB is your exit current. So therefore from here I am writing IB is equal to I1 minus of 0.1 V2. Make it as equation number 1. Now apply a super mesh analysis. So when we apply super mesh analysis, this equation becomes V1 is equal to 5 of I1 again here. So here that is minus of 0.3 V1, because here it is minus of 0.3 V1 voltage source plus 4 into, so in this one IB and I2 are entering currents now, IB plus I2. Okay, now expand this value and also substitute IB from the equation 1. So write down here, substitute IB from equation 1. Therefore V1 becomes 5I1 minus 0.3 V1 plus 4 into IB value is I1 minus of 0.1 V2 plus I2. Therefore V1 is equal to 5I1 minus 0.3 V1 plus 4I1, this is minus 0.4 V2 plus 4I2. So this is V1. So make this term 0.3 V1 to left hand side. So it will become V1 of 1 plus 0.3 is equal to 5I1 4I1 minus 0.4 V2 plus 4I2. So this is nothing but V1 of 1.3 and this is 9I1 plus 4I2 minus 0.4 V2. Okay. So here we are getting V1 in terms of 9 by 1.3 I1 plus 4 by 1.3 I2 minus 0.4 by 1.3 V2. So here they are asking the Z parameters. So Z parameters equations are in terms of V1 in terms of I1 and I2. Nothing but V1 is equal to Z11 I1 plus Z12 I2. Similarly V2 is equal to Z21 I1 plus Z22 I2. So from here we can say, but here we have the extra term V2 now. So similarly, so to find out this V2, apply a KVL to loop 3. So this is your loop 3 now. So this loop 3 is nothing but this V2 is equal to 4 into I2 plus IB. So from a given circuit, so the loop 3, the voltage V2 is equal to 4 into I2 plus IB. But here we know the value of IB now. So this is 4 into I2 plus IB is nothing but from the equation 1 we can say IB is equal to I1 minus of 0.1 V2. I1 minus of 0.1 V2. Therefore it is 4I2 plus 4I1 minus 0.4 V2. So here this is left hand side V2, this is here, make this term to here now. So we will get V2 is equal to 1 plus 0.4 of 4I1 plus 4I2. Now write down that V2 of 1.4 is equal to 4I1 plus 4I2. So therefore V2 is equal to 4 by 1.4 of I1 plus 4 by 1.4 of I2. So 4 by 1.4 value becomes 2.85 I1 plus 2.85 I2. Make it as equation number 3. Okay, now substitute this EV2 in equation number 2, that is V1 is equal to, substitute V1 is equal to equation V2. So here the so in the EV1 equation we have the V2 terminal, that is 9 by 1.3 of I1, 4 by 1.3 of I2, 0.4 by 1.3 of V2. Write down the equation here. So it is 9 by 1.3 of I1, 4 by 1.3 of I2 minus 0.4 by 1.3 of V2. So in this value substitute here V2. So here, so V1 is equal to this 9 by 1.3 becomes 6.92 of I1. Similarly 4 by 1.3 becomes 3.07 of I2. Similarly minus 0.4 by 1.3 becomes minus 0.307 of, substitute V2 here, 2.85 of I1 plus 2.85 of I2. So it is 6.92 of I1 plus 3.07 of I2 minus, calculate these values, 7 into 2.85. So it is nothing but 0.3, and here this is 2.85 common. So we are getting 0.3 into 2.85 becomes 0.876 of I1. Again this is minus, this term becomes minus 0.876 of I2. So therefore V1 is equal to, now subtract these values. So this is 6.92 minus of 0.876. So we are getting it is 6.044 of I1 plus, similarly 3.07 minus 0.876. We are getting it is 2.194 of I2. So this is your V1 equation. So rewrite the equation 3 here. So V2 is equal to 2.85 of I1 plus 2.85 of I2. So from this here we can say that these equations in terms of a z parameters, equations are v1 comma i2, those depends upon i1 and i2. So from here, so in general v1 is equal to z11 i1 plus z12 i2, v2 is equal to z21 i1 plus z22 i2. Now compare these equations, make it as 4 and 5. v1 is equal to z11 i1 plus z12 i2, v2 is equal to z21 i1 plus z22 i2. So make it as equation 6 and 7. So compare equation 4 with the 6, similarly 5 with 7. So therefore compare 4 with the 6. So v1 is equal to z11 of i1 plus z12 of i2. So therefore from here we can say z11 is equal to 6.044. Okay. Similarly z12 is equal to 2.194. Okay. 2.194 ohms. Impedance it is ohms. Similarly, compare equation 5 with the 7. So here getting 2.81. Nothing is z21. Z21 is equal to 2.85. Similarly, Z22 2.85. So write it in a matrix form. Z parameters 6.044, 2.194, 2.85, 2.85. So this is your Z parameters. So in the question they are asking the Z parameters and ABCD parameters. We know that A is nothing but a Z11 by Z21. Okay, so Z11 is 6.044 by Z21 is 2.85. So this value becomes 6.044 by 2.85. So this is 2.120. Similarly, B is equal to delta Z. Delta Z is nothing but Z11 into Z22 minus Z12 into Z21 by Z21. So this is Z11 is 6.044, Z21 is 2.85 minus 2.194 into 2.85 by Z21 is 2.85. So we'll get that value as 3.76 ohms. Okay. Similarly, C is 1 by Z21. So this value becomes 1 by 2.85, 0.35 mhos. Similarly, D is equal to Z22 by Z21. So Z22 is 2.85. This is 2.85. You get 1. Therefore, the ABCD parameters of a given network is 2.120, 3.76. This is 0.35. This is 1. So this is the answer. Okay, thank you.